Understand search scores with BM25 and boosts. You will leave knowing how BM25 ranks documents, how to compute simple IDF and term counts in Python, and how to push scores with query boosts and document priors to change ranking. I'm Professor Pi, teaching search and information retrieval from basics to advanced in simple Python. Search needs a way to score how well a document matches a query. BM25 is a classic ranking function used in real search engines. It solves keyword relevance quickly and cheaply. It excels on 3 to 100,000 document collections, and it is fast without heavy GPU cost. The downside is it looks for lexical matches and can miss deeper semantic relations that dense embeddings capture. At a high level, BM25 blends 3 ideas. First, how often query words appear in a document, which we call term frequency. Second, how rare those words are across the whole collection, which we call inverse document frequency, or IDF. Third, a length normalization so long documents do not win just by being long. Imagine a query with the rare word cat and a common word 8. The rare word should pull more weight. We will build a tiny pipeline step by step. You will see counting query matches, computing IDF weights, computing BM25 with length normalization, applying query boosts, and adding document priors to return the top 2 results. This snippet counts query term matches per document using simple tokenization. The code creates a tiny list of example strings in the variable docs and a short query named q to keep things readable. A small function called talk lowercases text and pulls out word tokens with a regular expression, making matching robust to case. The variable tf sums how many times the query words appear in each document, counting repeated occurrences when they exist. This gives a first, unweighted relevance signal before any IDF or BM25 math. The printed list shows which documents contain more of the query terms and hints at likely relevance. Now we will weight those matches by term rarity across documents. This example computes inverse document frequency weights for the query terms to capture how informative each word is. The list named terms holds the tokenized query, and a count named df tallies how many documents contain each term. Then the list IDF uses a smooth logarithmic formula so that rarer terms receive larger weights and very common words receive smaller weights. This mirrors how search engines reduce the impact of ubiquitous words while rewarding specificity. If a term appears in more documents, its IDF drops. If it appears in fewer, its IDF rises. The printed weights show each query term's discrimination power across the tiny corpus. Next, we'll combine counts and IDF into the BM25 ranking formula. This code calculates BM25 scores for each document by combining the term counts and the IDF weights. BM25 is a ranking function that sums each term's IDF times a normalized term frequency. The parameters K1 and B control term frequency saturation and length normalization, respectively. The average document length, AVDL, scales the length effect so that short documents do not get unfairly penalized. For each document, the term frequency sits in a denominator that grows with both count and document length, preventing runaway gains from very high counts. Increasing K1 makes term frequency matter more. Increasing B strengthens length normalization. The resulting scores are higher for documents that match the query terms with the right balance of rarity and density. Now we'll add a simple query level boost to favor important words. This snippet applies query term boosts so you can emphasize words you know are more important. The dictionary BQ assigns a larger weight to the word cat, while leaving 8 unchanged. During scoring, each term's BM25 contribution is multiplied by its boost, so favored words have greater impact. This is practical when domain knowledge says certain tokens are critical, like product names, model identifiers, or entity names. Increasing a term's boost will lift documents that contain that term and can change the rank order. The printed values show how emphasizing cat raises scores for documents that mention it and shifts results. Finally, we'll combine content scores with document-level priors and pick the top results. This example combines BM25 with document priors and returns the top 2 documents. The list pri encodes a prior weight per document that can reflect quality, recency, or authority signals. The code multiplies each boosted BM25 score by its prior, pairs scores with their document indices, and sorts them in descending order to rank results. Using a clear sort with a key keeps the operation deterministic and easy to follow. Raising a prior increases a document's chance to surface, even when content signals are similar. The printed tuples show the highest ranking documents and their final weighted scores. Recap: BM25 is a lightweight, interpretable ranking function that blends term frequency, IDF for rarity, and document length normalization. Use BM25 when you need fast, keyword-based relevance across small to medium corpora, and when interpretability matters. One caveat: BM25 focuses on lexical matching and can miss semantic matches without additional features like embeddings. Next step: tune the BM25 parameters K1 and B on a validation set, or add TF-IDF n-grams to capture short phrases. Then measure ranking quality with NDCG. If practical IR examples help you, subscribe and watch the rest of the Information Retrieval series.